And we're going to cover section 9.4 first, logarithmic functions and graphs. All right, logarithmic functions and graphs, page 633. And I'm going to start with a basic formula that I hope you've seen before. I gave that when I covered section 9.3. We talked about exponential functions, section 9.3. This was the basic, just the basic exponential model. And then today we're talking about logarithms. And so I'm going to give you the basic logarithmic equation. And it is log base b of y equals x. Log base b of y equals x. And y'all need to have both of those written down together, because one of the main things we're going to be doing is converting back and forth. I'm going to give you an exponential equation. You're going to have to convert it to log. Or I'm going to give you a log equation. You're going to have to convert it to exponential. Okay, you're going to have to know how to go both ways. Right? It's good to go both ways. So I'm going to give you a choice. Do you want to do calculator stuff first, or do you want to do non-calculator stuff first? 633? Calculator first? Okay, we'll do calculator stuff first. Let's start with number 12. And for number 12, we have log base 2, 64. And so the first thing you're going to have to know how to do is how to calculate the value of a logarithm. I'm going to show you how to calculate the value by hand. Are you ready? So the first step is to notice that the 2 is the base. This 2 is the base of the logarithm. I need you to convert 64 into 2 to some power. Okay, so 2 to what power is 64? Can't be 32 power. 2 to the 32 power is way bigger than 64. Is it 2 to the 6th? Does anybody agree that 2 to the 6th is 64? Yeah. Okay. And now what I want you to notice, now the bases match. So this little 2, this is the base of the logarithm. This 2 is a base because he has a power. So these are both bases. Do y'all see that they match? Okay, so when the bases match, they cancel. And the answer to that problem is 6. Do you see how it works? You've got to get the bases to match so they'll cancel. Go ahead. Right. So let's talk about button pushes, since y'all, I know y'all like to push buttons. Okay, y'all push my buttons all the time. So if you notice on your Casio, y'all got your Casio handy? You've got 3 log buttons. There's an LOG, log button. There's a LN. Do y'all see the LN right below the LOG log? And then you've got a third log button that has boxes on it. Log with a square and a square. That's the button you want. So push the log button that has the squares, and then simply put the 2 in the 64. And does it give 6? Okay. Now, does anybody have any other calculator and need button pushes for your particular calculator? Anybody using a calculator that's not the Casio? Because I can give you button pushes for it. Does everybody have my calculator then? Why are you not asking for help if you don't have it? Do you have my calculator? Do you have any calculators? What do you have? Oh, okay. Where's your 84? No, not on your phone. Do you have one in person at all? It's a man. And then hit the F arrow. And see that log base? Okay, so that's how you get to it on that. Anybody else need calculator counseling? Is that your calculator? Okay. Because I was going to show you how to do it on that too. Although I would rather not. Anybody else back here? Where's your regular calculator? Oh, yes. What about back here? Calculator? Oh, that's 84. Can we look at how to do it on there? Okay. So, what you want to do is push the math button and with the up arrow, and at the very beginning, and then the all there. No, that's not the one. This button won't do that. Now, did that get everybody so that you can use your calculator? Okay, fine. Let's go try another one. Let's try number 15. We've got log base 2 of 1/4. And I want to calculate the value. What is log base 2 of 1/4? And again, with the calculator, let me rephrase that. With the right calculator, this is super easy. -2. Okay, but then the question becomes, what if I put this on a test and I say must show work? Then you're going to have to know how to crank it out by hand. So let me show the work. This is going to be log base 2, 1/2 squared. Does everybody agree that 2 squared is 4? And then I can move the 2 up. And what will that do to his exponent if I move it from bottom to top? Did y'all know that property of exponents? If you move from the bottom to top, it's going to change the sign of the power. And now do the bases match? And now they'll cancel. And look at that. I get -2 for the answer. That's how you show work. Can I say what again? Okay, I'll do it again. You want me to do the exact same one over again? You want to do a different one? Okay. Let's do a different one then. Can I make up my own problem? Okay. Let's see here. How about, let's say that we have log base 3 of 1/27. How about log base 3 of 1/27? Okay, so 27 is 3 to what power? Is it 3 to the third? 3 times 3 times 3, 27. So all I'm doing here, I'm just rewriting 27 as 3 to some power. And then I'm going to take the 3 to the third and move it up, which is going to change the sign of the exponent. And now I can see the bases match, so they'll cancel.
How would you find it, like by hand, let's say, for 12, how did you know it was 2 and 6? How did you find it out?
You would have to take your calculator and go 2 times 2 times 2 times 2 times 2 times 2, and just keep timesing by 2 until you get to 64, and then count up the number of 2 you used. That's the shortest way I know of to do it. Because you can't say, well, I'm just going to take the 6th root, because I don't know that it's a 6. Yeah. Any other questions before I move on to the next new thing? Okay, so a couple of more problems that I'm going to make up. What about log of 1,000? Log of 1,000. Now, do y'all see when I wrote this, there's no base here. So do y'all know what the base is if there's no base visible? No, 10. Y'all need to know that. If there's no base showing, what is it? 10. But this also means that you can use that other log button, the button that just says log, log, and just do log of 1,000. It is 3. Okay, I got another one. How about natural log of 2.72? What is natural log of 2.72? Do y'all have an ln button? Okay, so use that button and do ln 2.72, and it's 1. So if I round it, 1. Cool. If I round it to the nearest whole number, it's 1. Okay, one more thing I need to explain before I move on. ln means log base e. You need to know that. ln, natural log, means log base e. So anytime that you see log base e, can you rewrite it as ln? Yeah, because ln is log base e. Those are the same thing. All right, so let's get back to the book and make sure that I stay on track. Number 39. We've got e to the third equals t. Now this is getting into new territory, okay? We're not calculating the value anymore. Now it says convert to a logarithmic equation. So can everybody see that this equation is exponential? It's got an exponent, doesn't it? This is exponential. I need to convert to a log equation. And so that's where we're going to use this converter up here. We're going to use this mess and convert it to log, okay? So this is going to be log. And then where does the base come from? It's whatever has the power. So what has the power here? The e does. So that means the log is going to be base e. And then it says log base b of y. Where does the y come from? It's the t. Do y'all see this is on the other side of the exponential? And so that's going to be the t. And there's only one more piece of the puzzle. So what is it going to be equal to? 3. And can y'all see from up here that whatever the exponent is on the opposite side of what the log is? It's going to be log base something of something equals the exponent, which is equal to 3. Now, did that seem a little confusing? Yeah, I meant for it to be a little confusing because I have a shortcut. I have a way to make it easier. So, Dustin, you're just in time for poetry. Yes, it's poetry time. Are you ready? So, to convert from exponential to log using a poem, the poem goes, bring the base down, switch the other two around. Are you going to write it down? Bring the base down, switch the other two around. What's that? Really? Oh, cool. Cool. Bring the base down, switch the other two around. Bring the base down, switch the other two around. So, if I look at my exponential equation here, what is the base? So we're going to take the base and we're going to bring it down. Bring the base down, switch the other two around. Do you see how that works? Okay, can we do another one? I'd like to do number 43. P to the k equals 3. P to the k equals 3. And I want to convert that equation into logarithmic form. So what is the base? Let's bring it down. That's going to be log base P of 3 equals K. Does everybody see how that's working? Does anybody have any questions? I may have to ask y'all to leave if y'all can't be quiet during my lecture, okay? Anybody have any questions about going from exponential to log? Because guess what? We have to go the other direction too. So we're going to do number 47. And that's going to be log of 0.01 equals negative 2. And does everybody notice that this problem does not have a base on the log? Do y'all see there's no base visible? What is it understood to be? 10. So we're going to fill that in. And the instructions say convert to exponential form. And guess what? My poem still works. We're going to bring the base down, switch the other two around. Now, what is the negative 2 going to become? Exponent. Because the 10 is a base. And so he needs a power. And now we have converted to exponential form. Does everybody see how that works? Would you like to try one more of those? Okay. Let's do my problem. I'm going to make one up. Let's do natural log of x equals, I don't know, what's a good letter we don't use nearly enough? S? Okay. S. Natural log of x equals s. And I want to convert that equation into exponential form. Again, I do not see a base. What is it understood to be for natural log? Ln is log base e. Ln is log base e. And so now that we can see the base, we're going to bring it down. Bring the base down. Switch the other two around. And I bet if we would have been a little more creative with the letter placement, we could have spelled sex. I just didn't put enough thought into it ahead of time. All right, so now we've converted from log to exponential and from exponential to log. Do you think you can go both ways? It's good to go both ways, okay? So let's see what can we do next. Let's do number 63. Natural log of 2. And it does say use a calculator. So I'm going to need you to calculate that value. I need it rounded to 4 decimal places. Anybody? 6,931. 0.6,931. Everybody agree with that? Okay. Yeah, there's a little bit of difference between that and actually 6,931. Cool. Is everybody able to get that? Okay, let's do another one. Let's do number 69. Log base 4 of 100. Log base 4 of 100. Again, I need you to use a calculator, and I need that rounded to 4 decimal places. 3.3219. 3219. Is that rounded correct to 4 decimal places? And again, is everybody seeing that you cannot get those answers if you don't have a calculator? I'm sorry, and know how to use it. You have to have a calculator and know how to use it. Okay, so I'm about to dive into new territory. Number 79. And let's do this. Let's go. All right, so looking at this function, can you tell me, is this exponential or logarithmic? Exponential, because it has an exponent, right? You don't see log anywhere, do you? So this is an exponential function. The first thing I want to do with that, I want to graph it. So I'm going to need you to pick me some really nice x's. 0's a good choice. -1 and 1. Yeah, those are good choices. And let's plug those in and generate the y values. What is 3 to the negative 1 power? 1/3. What about 3 to the 0 power? And lastly, 3 to the first power. And then we're going to take those numbers, those ordered pairs, over here to the graph, and we're going to plot them. Let's see here. 1, 2, 3. Okay, so negative 1 is up at 1/3. That's not very high. 0 is up at 1. And 1 is up at 3. Now, how many of y'all remember I covered 9.3 last time? Remember 9.3? And I said every exponential function has a horizontal asymptote. Do y'all remember that? This is an exponential function. It's going to have a horizontal asymptote. Where's the asymptote going to be? At the x-axis. Can y'all see it coming in closer to the x-axis? And so we're going to connect the dots. And I'm going to use brown. For whatever reason, I'm going to use brown. Brown. Bam. Like that. So far, so good? Yes? Okay, now what we're going to do, now I've also covered how to find the inverse function, correct? Y'all remember the 3 S's? Substitute, switch, and solve? So now we're going to find the inverse of this function. So the first thing we're going to do is we're going to replace f of x with y. Remember, that's the substitute step. We're going to substitute f of x and replace it with y. What's the second S? Finding an inverse function, what's the second S? Switch. We're going to switch x and y. And can y'all see now that the y is up in the exponent position? So what is the third S? So I'm going to have to solve for y. Can y'all see? I'm going to have to get y by itself, but he's way the hell up in the exponent. He's like freaking Zacchaeus. Y'all remember your Bible stories? Remember Zacchaeus? You come down. Never mind. I'm going to have to get this y to come down somehow. And you're about to see why logarithms are even needed in math, okay? Because now we're going to do the poem I just taught you. We're going to bring the base down, switch the other two around. Bring the base down. That's going to become log base 3. And switch the other two around. Y and x. And do you see how nicely that isolates y? That's the only reason really that logs were invented, was to find the inverse of an exponential. They had to have some way to get that y down from the exponent, and they said, well, we're going to need logs. Yeah, so now this is the inverse function, log base 3 of x. And now guess what we're going to do with that inverse function? We're going to graph it. We're now going to graph this, okay? So are you thinking we're maybe going to have to pick x's and plug in for y? No, no. Look at this table I already got here, right? Aren't these ordered pairs for this function? Right, well, they're going to work for this function also. all I have to do is switch, switch, and switch. Did y'all know that was that easy? If I've already got ordered pairs for this function and this is the inverse, then these will just switch. So let's make some ordered pairs. One of the ordered pairs for the inverse function is going to be 1/3 -1. The other one's going to be 1 and 0, and then 3 and 1. And this only works, this switch in the ordered pairs only works if this function is the inverse of the original, okay? Only for inverse functions. So now let's graph those points. 1/3 is at -1. 1 is at 0. And 3 is at 1. And so again, I'm going to grab my brown marker. I don't know why I'm picking brown. There's got to be a reason for that. Look at that. Do y'all see that? Okay, I'm about to say something important. Do y'all remember that I said every exponential function has a horizontal asymptote?
Yes.
Okay, guess what every log function has? Vertical asymptote. Can you see this function coming in here? It's coming in and approaching the y-axis. And so the y-axis is going to be the asymptote for this function. This other brown graph here, this is the log function. Did y'all write that down? Every log function has a vertical asymptote. Okay, so now I'm going to grab my green marker. We're going to go like that. And we're going to come in and say bam. Look what I grew. Do y'all see what I grew? A symmetry. I grew a symmetry. I've been doing that for years now, actually. But y'all do need to notice that this brown graph, if I fold it across diagonally, do you see it makes the other one? And remember, we talked about that when we did the inverse functions. We said that a function at its inverse is always symmetric about the line y equals x. I think it's just kind of cool that for exponential functions, it actually makes a tree. It does make a symmetry. Man, you're not going to get that in other math classes. Y'all better Snapchat that or Instagram it, whatever y'all do. Okay, and there's one more that I'd like to do, and then we'll move on. Number 83. And number 83 says, we've got f of x equals log base 2 of x minus 3. Okay, so for this problem, they just straight out give me a log function, and the instructions say graph. That's all it says. All you got to do is sketch the graph, okay? Now, just a second ago, I said every log function has a what? What did I say? Vertical asymptote. And so what I'm going to do first is I'm going to teach you how to find the vertical asymptote. So the vertical asymptote can be found by taking the x minus 3 and setting it equal to 0 and solve. Okay? So whatever you're taking the log of, if you set it equal to 0 and solve, that's where the vertical asymptote will be. And so if I move that across, that's going to be x equal 3. That's going to be my vertical asymptote. Anybody have any questions so far? Okay, so let's go to the graph. 1, 2, 3. vertical asymptote. And then I'm going to need some points. Okay, 1. Well, time out. Before you pick too many, let's do 1 and see what it works out to be, okay? Now, do you understand I have to plug it in here? Okay, so that means on your calculator, I need you to calculate log base 2 of 1 minus 3. Log base 2 of 1 minus 3. And you should get an error message. Yeah. That means the graph is not going to exist over here. Okay, so pick me a different x and maybe it will come out with a point this time. 0. So do log base 2 of 0 minus 3. Error. I just said the graph is not going to exist over here. 5. So I need you to do log base 2 of 5 minus 3. And it came out to be a whole number 1? Awesome. Let's plot it. 1, 2, 3, 4, 5 is up at 1. 5 is at 1. Okay, we've got to start. I'm going to need probably a couple of more good x's. 8. Log base 2 of 8 minus 3. And I don't think that's going to be a nice number. Okay, so about 2.3 if we round it. And so that means 1, 2, 3, 4, 5, 6, 7, 8. 2 is going to be at 2.3. Somewhere about there. Okay, would y'all mind if I pick one? Okay, I think I'd like to know what's going on a little bit closer to this asymptote. So where's the asymptote at 3? Have we used 4 yet? Okay, let's see what happens if I choose x to be 4 and get a little bit closer to this asymptote. Log base 2 of 4 minus 3. 0? Aha! I see kind of what's going on here. I've got kind of a curve going on here. Do y'all see that from those 3 points? It's kind of curving up to the right. What do you think is going to happen as I get closer to the asymptote? What do you think it's going to go like that? Or do you think it's going to go like that? Okay, me too. I think it's going to keep curving down and get closer and closer and closer to the asymptote, but never touch. Anybody have any questions about graphing a log function? Do y'all see how to find where the asymptote is? Okay, good. And that means that I'm done with that section and I need to move on to the next section. Anybody need me to keep this page up for another few seconds? Rachel, you good? Okay, here we go. Next page. 9.5. And if you have a book and want to turn with me to page 643, in section 9.5, we're going to be talking about the properties of logarithms. And I've got 3 formulas for you. There are 3 properties we're going to look at. The first one is called the product rule. Okay, so what the product rule says, it says if you're taking the log of 2 things that are being multiplied, you can actually take those factors and separate them into their own log. Do y'all see that? If I have two numbers or letters or whatever, if I'm taking the log of those things that are being multiplied, I can take those factors and separate them. They each get their own log cabin, and multiplication turns into addition. Multiplication turns into addition. Questions about that? Okay, next, the quotient rule. And the quotient rule says if I'm taking the log of a fraction, the numerator and the denominator can get separated each into their own log, and a fraction turns into subtraction. That one rhymes. A fraction turns into subtraction. And the last property is the power rule. And the power rule says if you're taking the log of something that has an exponent, the exponent can become the coefficient. Everybody writing those down? I see a lot of people writing those down. That makes me feel good. Okay, so again, just a brief overview. The product rule says that multiplication turns into addition. The quotient rule says that a fraction turns into subtraction. And the power rule is like the Price is Right. Look at the exponent. He gets to come on down to the front, right? You're the next contestant on the power rule. Okay, and so now we need to look at examples. We're going to start with number 7. Problem number 7. We've got the natural log of xy. Now, which one of these properties is demonstrated here? The product rule, because I'm taking the log of 2 things that are being multiplied. So the x and the y are going to get separated. Maybe it's only a trial separation though. They each get their own log cabin. And multiplication turns into addition. Oh, look at that. That's done. That's all there is to that. Okay, next problem. Let's look at number 21. How about the natural log of r over s? Quotient. This is the quotient rule. I'm taking the log of a fraction, So the R and the S are going to get separated. And a fraction turns into subtraction. And that's done. Everybody see how that works? Okay, next problem. Let's do 11. Log of y to the 8th. What rule? Power rule. And where does the 8 get to go? Yeah. Listen to this. That 8 is going down. Oh, he's going down on the log. Just like that. And so what I've done here is I've done an individual example of each property separately. And so now we're going to look at problems where you might have to do more than one property in the same problem. So do you want to take baby steps, or you want to just go for the big one first? Baby steps. Okay. Let's do, well, to take baby steps, let's do my problem. I'm going to make one up. This is my problem. And let's say that we have log base 7 of, how about 49x? Log base 7 of 49x. So what is between the 49 and the x? Multiplication, right? That's 49 times x, and that's going to be the product rule. So if I separate that, that's going to be log base 7 49, and then what sign? Plus log base 7x. Do y'all see how that works? The 49 and the x, they got separated, each in their own log cabin. And if you stop there, you get partial credit. Because does log base 749, does that simplify? What does it calculate to be? What is log base 749? Is it 2? And does everybody see sometimes you can actually take it a step further and simplify? Everybody see how that works? Or do I need to show work? Yes or no? That's good enough? I'm not getting much feedback. Oh, show work. Okay. Okay, so here's what I would do if I want to show work. Can I rewrite 49 as 7 to some power? Does everybody agree that 7 squared is 49? And didn't we say if the bases match, they cancel? Right? Cancel, and that's where we get the 2 from. How was that? Was that good enough showing my work? Okay, next, let's go to the book and let's do number 26. And number 26, we've got log base b of x squared y over b to the third. And I don't know, those of you, if you've got your textbook open in front of you, you may see that there's no parentheses. I put the parentheses myself. Those parentheses are optional. Sometimes it just feels good to put the parentheses though. Do y'all see the parentheses tell me that I'm taking the log of all of this? Okay. So in this problem, do you see multiplication, a fraction, or a power? Okay, power. There's a couple of powers. There's multiplication. Is there also a fraction?
Yes.
Oh my gosh, we've got all three rules this time. And so you're going to need to know in what order to do them in. It turns out that the quotient rule always goes first. So if you have a fraction, you have to break it down first. Next, any multiplication needs to be separated. And the last thing that you deal with are the powers. Okay, so the first step, a fraction turns into subtraction. And it's going to be log of the top minus log of the bottom. Log of the top minus log of the bottom. At this point, do you see that this log here at the back has bases that match? And if the bases match, they cancel. So right at this point, I can go ahead and cancel those b's because the bases match. Okay, next step. Now I'm going to have to take the x and the y and separate them. So that's going to be log base b of x squared plus log base b of y minus 3. So far, so good? And then I've got one more step and I'm done. Now the power rule. Where does the squared get to go? He comes down to the front. That's going to be 2 log base b x plus log base b y minus 3. And that's about as nasty as you're going to see it in this class.
When does it get nastier? Which class is this?
You have to go up. Like
calculus, we're going to see this all over again, but nasty?
You're going to see it applied within calculus stuff. Yeah. So I'm not going to say that it gets more complicated. You're just going to see it again, but it's going to be within other stuff.
Within like a different problem?
Right. Like maybe an integral or a derivative, stuff, calculus stuff. And within there, you may have logarithms that you have to know how they work. Okay, so at this point, what we've done with these properties is we've done what is called expand. We've taken a single log and we break it up into several logs, right? Guess what we're going to do now? The opposite. Now we're going to take a lot of logs and put them together into one log. You're going to have to know how to go both ways, okay? So before I get away from this, do y'all feel pretty comfortable breaking it down? Or do you need to do one more example of breaking it down before we build it back up? Because I've got time. Okay, well, I'll tell you what I'll do. I'll make up one more, and I'll make it close to a test question, like what you might see on the next test. So you might see something like this on the next test. Natural log of 5x cubed over z to the 4th. it's possible that you could see something like that on the next test. And you'll have to know how to expand. I think the key word that you're going to see in the instructions, it'll say expand. And that means we want to separate it up into many logs. Okay, so in this problem, do you see multiplication, a fraction, or a power? All the above. What do I have to deal with first? Yeah, the quotient rule. So we're going to take down the fraction. And that's going to be natural log of the top minus natural log of the bottom. Remember, a fraction turns into subtraction. Next step. What about the 5 and the x to the third? We're going to have to separate them. They each get their own log. And what does multiplication turn into? Addition. And then the last thing that you get to do is you get to bring down the powers. How many people have ever heard the phrase divide and conquer? That's exactly what we're doing here. We're dividing the enemy up into separate cabins, and then we can take down his power. Right? We're going to take out his power. And so where do the powers get to go? Down to the front. Bam, down to the front of their logs. Last step, natural log of 5 plus 3 natural log of x minus 4 natural log of z. And that is expanded completely. Got it? Okay, now we're going to put them back together. And that's going to take us to problem number 35. 35, we've got log base A 75 plus log base A of 2. And now if you're trying to decide what property to use, you're going to have to look at the sign in between the logs. So this time we have addition. Which property does that go with? Yes, that goes with the product rule, right? So addition is going to turn back into multiplication. And remember a while ago when I said maybe it's only a trial separation? They're going to get back together here, okay? They're even getting married. Look, the two logs become one. The two become one. And their stuff gets times. And the final answer here is going to be log base A of 150. Yes, you do need to go ahead and multiply 75 times 2. Are you ready for the next one? Okay, number 38. We've got natural log of 54 minus natural log of 6. And this time I have subtraction. That's going to turn into a fraction. And again, the two logs become one. And who goes on top? And then you do need to go ahead and divide that if it will divide. 54 divided by 6? Natural log of 9. Any questions? Ready for the next one? 39. we've got 1/2 log of n plus 3 log of, why did I make that a base? M. I was thinking about a base, I think, and that's why I made it a base. Now, what I want you to notice about this problem, did you notice not only do we have the plus in between the logs, did you notice we also have coefficients? The 3 and the 1/2, and that's going to be the power rule, right? Normally the exponents go down to the front, but when you're condensing, the numbers in front become powers, and that has to happen first. So if you have numbers in front of your logs, you've got to make them become exponents again. So that's going to be log of n to the 1/2 power plus log of m cubed. Did y'all catch that? The numbers in front have to be dealt with first, and then I can deal with the addition. So what does addition turn into? Multiplication. So that'll be n to the 1/2 m to the 3rd. Taking the log of all of that, or you could say log of m cubed square root of n. You could actually write it like that. Did everybody know that a 1/2 power means square root of? If you didn't, this is a nice time to grab that information. Square root means to the 1/2 power. So a 1/2 power means square root of. And do you know why you might want to do that sometimes? Sometimes you just feel like getting radical, dude. You know what I'm talking about? That's math humor. You just got to get radical, dude. Okay, fine. Any questions about that? Okay, before I do my last problem today, I'm going to do a refresher real quick, ask you some questions, and see if you've learned anything. When there's no base showing, what is the base understood to be? So log with no base is log base. What is the base for ln? E. That's log base E. And you need to know both of those. Okay, last problem today. Let's see. You know what? I think I'm just going to make it up. My own problem. Something like what you might see on the next test. Okay? Let's do 3 log base. What's a good base? What's a good letter we don't use nearly enough? S? S. Log base S of x plus 2 log base S of y minus 1/3 log base S of z. There we go. That's a good proper test question right there. You could see that on the next test. Man, how many logs are there? The correct answer is too many. There's too many logs. I want this problem to have only one log. And so do you see any numbers in front of the logs? That's what I'm going to have to deal with first. So where do the 3 and the 2 and the 1/3 go? Right. They're going to become the exponents of the x, y, and z. So that's going to become log base s of x cubed plus log base s of y squared. Notice that I'm not taking the minus with the 1/3. Do you see that? I'm only taking the 1/3. The minus stays there. Minus log base s of z to the 1/3. So far, so good? Now, the next step, we're going to work our way from left to right. I'm going to put these first two logs together. Do you see that they have addition? So what does addition turn into? And that'll be x cubed y squared minus log base s z to the 1/3. And now for the last step, I can put the last two logs together. This time I have a subtraction. That'll turn into a fraction. And does it matter who's on top? Yes, it does. All over. And can I do that if I want? Oh, sometimes you just got to get radical, dude, okay? Yeah, y'all need to know that a 1/3 is the same as a cube root. But what if I left it z to the 1/3? It'd be okay. It'd be okay. And that's the final answer. And I am done for the day.